In today's lesson, we're going to do 3 word problems that resemble much like the questions you did last year. So we'll do 3 together, and then we'll just let you practice tomorrow in class with the problems. The first thing you do when you read the question is identify what it is you're trying to solve for. In most of today's questions, we're looking for the roots or the solutions, which just means things that make the left side and the right side of the equals true. But for us today, we need to write the equation first. So we're first going to look at a rectangle has a length that is 4 centimeters longer than its width. The area is 117 centimeters squared. Determine the dimensions of the rectangle. So we're looking for roots. So the first thing we have to do is identify what our x and y values are. So we're going to let x in this case be the width. Really, you could let it be the length as well. It doesn't matter. For the length, it says the length is 4 centimeters longer than the width. So we know that we have x plus 4 is going to be equal to the length. Now we don't want to have x and y's or different values here because it's really difficult in an equation to solve for 2 different unknowns. So here's our general equation of area equals length times width. Because that's what we know. We know area, so we must use our area formula. The length is x plus 4, so we substitute in what we know from above, and we know that our width we called x. So now we have only one unknown, just x's throughout the problem, so that keeps it nice and simple. We know that the area was 117 centimeters squared. So we're going to bring the 117 over to the other side, which means that it'll always just change signs. And I'm going to do distributive property at the same time here. Distributive property. So x times x is x squared, and x times 4 is 4x with the negative 117. So in order to find solutions, zeros, things that will make the left side and right side equal to each other, we can factor or quadratic formula. So figuring out whether you can factor or not just takes some guessing. Take some guessing on what 2 factors of 117 will add or subtract to equal 4. If you use the quadratic formula right away, you'll get to the exact same answer. It just may take you a little bit of time, a few extra steps. But here I know that positive 13 and negative 9 multiplied together give me negative 117, and they also add to give me positive 4. So therefore, my solutions that make this statement true are negative 13 and positive 9. So I know I can't have a negative width. So that x value does not help me at all. Now that I have my answer of x equals 9, I always go back, reread the question, and see what was being asked so that we do our therefore statement properly and we don't answer the wrong question. So we want determine the dimensions of the rectangle. Good, so the dimensions are, what units? Centimeters. The dimensions are 9 centimeters by 13 centimeters. And there you have it. All right, we'll start our second example. Suppose the profit function for a product is p at x equals negative 1/2 x squared plus x minus 24. So it's nice we're given the equation here. We don't have to write it. We know that x is the number of products sold in hundreds, and p at x is the profit in millions of dollars. So sometimes it's always good to sort of organize your thoughts a little bit. We know that on our x-axis, this is number sold, and we know that that's going to be in hundreds. And I know that my profit here, my y, is going to be money in millions. So I want to determine the break-even point of the quantities. So that means I want where the profit is 0, no money lost, or no money gained. So I must be looking for the zeros right on the x-axis. I'm looking for where the parabola, and I know it opens upside down because it's negative. I'm looking for what are those zeros there where there's no profit, but also no loss. So we always make 0 on the left, because that's what we're looking for, when y is 0. So we have 1/2 x squared plus 8x minus 24. So the first thing I'm going to try and do is factor, and I can factor out negative 1/2 from all of the questions. Negative 1/2, I'm left with x squared minus 16 plus 48. And then I'm going to look for magic numbers, see if I can factor this further inside the brackets here. And I know that negative 12 and negative 4 works. Negative 12 times negative 4 is positive 48. And they also add to be negative 16. So my zeros in this question are when x is 12 and x is 4. So I have to remember that my x is the number of sold in hundreds. So what I really have here, when I do my therefore statement, that's why it's important to reread the question before you do it. The number sold is 1,200 or 400. Both of those amounts will have a break-even profit of $0. Okay, last question for the video today. Suppose tickets for a 36-seat bus will sell out with no excess demand of tickets if they are $25 each. So if we sell tickets for $25, the bus will sell out for 36 seats. For every $2 I increase that price though, I'm going to sell one less ticket. What price should be charged if the company wishes to have a revenue of 106? So again, sometimes it's good to organize just sort of what's happening as far as the parabola goes and what we're going to make our x and y values. So when we read the question, we need to have x be the unknown, what it is we don't know. And for here, our x is the number of times that we should increase the price. That's what we don't know what to do so that we have the best amount of money made, the best revenue. The number of times we increase, we'll just do it there, the price. So it's really important to start with that x value first so we know. Revenue, it's also good to keep in mind that what revenue is all the money that comes into the company. So it's the number of tickets sold for whatever it is you're talking about, number of tickets sold, multiplied by the cost of each ticket. If we multiply those two things together, we have a total amount of money that comes in. So let's just look at the number of tickets sold. Let's see what it tells us here, that if we start by selling 36 tickets, but every time we increase the price by $2, we're going to sell one less ticket. So as far as number of tickets sold, we're going to have 36 tickets, but we're going to decrease, we're going to subtract, we're going to lose a ticket sold every time we increase the price. It's going to be one ticket loss for every time we increase the price. So let's look here at the cost of tickets. What's it telling us? That they're $25 each, but an increase of $2 every time we increase the price. So we start at $36, and there's going to be an increase of $2 for every time we increase the price. So you can see here, if we increase the price 3 times, we're increasing by $6. Also, if we're increasing the price 3 times, there's going to be 3 less people that are going to attend. So this is my revenue function. My revenue function really has 2 different formulas in it. It has the number of tickets sold, small formula here, and the cost of the tickets. So here we've got on our x-axis is number of increases of the ticket, and here we're going to have revenue. Now we're already in factored form. So let's figure out, if we just need the zeros to the question, we're already there. We don't need to do any extra work. So what price should be charged if the company wishes to have a revenue of 1,056. Okay, so we're not looking for zeros. We need a revenue of 1,056. So what that's telling us, let's look as if we had the parabola here. We need to know how many times to increase the price so that we have a revenue of 1,056. So we need to know there and there what our x value is. So we can solve, but we're going to have to do some expanding and also bring that 1,056 over like our other questions. So when we first expand, I'm going to do my x's first. -1 times +2. That gives me -2x squared. And then I'm going to do here, -1x times 36 is -36x. And then I'll multiply my 36 by 2, which is 72x. And 36 times 36 will give me 900. Now I bring that 1,056 over and gather some like terms so it's a little bit neater in here. Squeeze that 5 in. Again, I can gather the like terms right at the end there. -2x squared plus 47x minus 156. So at this point here, in order to solve for the x, like in other questions, you can either factor by decomposition, or you can put this into your quadratic formula. Now I know that this won't factor, so we're going to go ahead and use the quadratic formula. Make some more space here. So our quadratic formula is x equals -b plus or minus b squared minus 4ac all over 2a. So if you want, this is a really good time to pause the video, substitute in yourself and see if you get this, and then replay the video, see if you get the same answer that I did at the end. Put that all over 2a, 2 times -2. So to erase that, I missed the 2. This is going to be 1,248 there. Do this along with your calculator. Be sure that you're getting the same numbers that I am. More room. So our first x solution could be -47 plus or minus the square root of 961 all over -4. Sorry, I'm just going to erase the subtraction there. So we'll make the first one be when we add, and then our second solution is the -47 subtract the square root of 961 all over -4. So when you put all of that in your calculator, you come up with a first solution of 74. And then your second solution comes up with an answer of 4. So let's go all the way back up now. After we've done all this work, we always need to remind ourselves what was being asked. So what price should the company charge if they wish to have a revenue of $1,056? So our two options that give us a revenue of $1,056 is increasing the price 74 times or increasing the price 4 times. So we can increase the price 4 times. If we just sort of think of it as our graph here, or 74 times. The 4 times is probably the 4 times is probably the most realistic, because who's going to pay that much for a bus if you increase it 74 times? So I'm just going to remember that our original price is $36, and if I'm going to increase it 4 times, it increases by $2 every increase. So that gives me 36 plus 8 for a total of $44 per ticket for anybody that wants to get on this bus. So it's really important when you do all that work to go back and actually answer what was being asked, because it's possible they could have asked you how many tickets did you sell, etc. And then you can finish with your therefore statement.